This is a pre-algebra video on solving two-step equations. So we will have an equation that might look something like this. We might have let me get the pen here. We'll have something like 3x plus 5 is equal to 20. Now you could probably guess what that is, but I want to choose simple numbers here to make it easy to understand at first. So, as always, my goal is to get the variable by itself. So here I want to get x by itself, and I'm going to keep doing things to get x by itself, but whatever I do to one side, I have to do to the other side. You can sort of think of that as the golden rule of algebra. Okay, so we're going to do that first. Now, in two-step equations like this, you usually do the addition or subtraction first, which I have messed up on spelling subtraction, but we will get rid of that. You usually do the addition or subtraction first, and then you do the multiplication or division, undo the multiplication or division. So on looking at this, I have 3x plus 5 is equal to 20. So I want to undo the addition or subtraction first, so I want to undo this plus 5. So what I'm going to do is get rid of that plus 5. I'm going to go over here and I'm going to subtract 5 from this side. Now, if I do it to the left side here, I also have to do it to the right side. And as I do algebra, I always work straight down. So I'm going, here's where my equal sign is. And so I have 3x plus 5 minus 5. That just leaves me with 3x. And I have 20 minus 5 over on the right side. That leaves me with 15. Now I have 3x is equal to 15. I want to get x by itself. So I can do that by dividing the left side of the equation by 3. And then the 3's cancel. I just have x. But I can only do that if I divide the right side by 3 also. And so on the left side, I end up with x. And on the right side, I end up with 5. And as you know, we can always check these. The check is always to rewrite the equation, the original equation, and then we're going to substitute what we have found here. X is equal to 5. We're going to substitute 5 for x, so we go 3 times 5 plus 5, and we're testing whether that is equal to 20. And 3 times 5 is 15, and plus 5, and we're testing whether that is equal to 20. And indeed, 15 plus 15 is 20. And on this side, we have 20 also. So we get a true statement that 20 is equal to 20, and that checks. Okay, let's do another one that's slightly different. I'm going to draw a line down here to give myself some room, and I'm going to pick a different color. I'll pick purple here. So on this one, it looks a little simpler, but it's actually a little tricky here. It's 6 minus w is equal to 18. Well, I want to get rid of that 6. And so I subtract 6 from both sides. And that's 6 minus 6 is 0, but then it still have 0 minus w. That's the opposite of w. We could say negative w, but we don't really know what w is, so we'll say the opposite of w is equal to 18 minus 6 is 12. Well, I'm just about there. I have the opposite of w is equal to 12, but I don't want negative w or the opposite of w. I want plain old w. So what I'm going to do is I could multiply this side by -1, and we know a negative times a negative is a positive, so that will just give me W. But if I multiply the left side by -1, I also need to do that to the right side. So I go ahead and do that. And so on the left side, I get W, and on the right side, I get -12. So W is equal to -12. I won't go ahead and check that one. We'll just leave that one alone. Here, I have room for another one here that I'll do. Let's pick a different color. I'll pick red here. So the next one is going to involve a little division here. So let's say I have -10 minus m over 8, and that's equal to 20. Okay, well, I want to do my addition, undo my addition or subtraction first. So I want to get rid of that 10, -10 there. So if I add 10 to both sides, that will do that. And if I do it to the left side, I also need to do it to the right side. And then I get -10 plus 10 is 0, but then I have 0 minus m over 8. That's still a negative, or the opposite of m over 8 is equal to 30. Now, I can get rid of the 8 there by multiplying both sides by 8 over 1. But I want to get rid of that negative sign also. So what I'm going to do is multiply it by -8 over 1, because a negative times a negative is going to be a positive. So the 8's are going to cancel, and negative times a negative is a positive. On the left side, I am left with just m. But since I multiplied the left side by -8, I have to do that to the right side also. I didn't leave myself room to do that, but I'm just going to put -8 here. That's 30 times -8. And so I get 30 times -8 is a -240. And that is my answer. I'm going to do a couple more problems here. So I'm going to get rid of this here. So let me get a new page, and we won't save this. The next one, sort of similar, but let's have a little more practice with, we have x over 2 plus 7 is equal to 17. Well, usually do the addition or subtraction first, so -7, do it to the other side also. So I get x over 2, because plus 7 minus 7 is 0, so I'm just left with x over 2 there, coming straight down. 17 minus 7 is 10. Now, I want to get rid of this 2. I'm going to multiply this side by 2. I can put that over 1 if you like. Since I multiplied that side by 2, I'm going to multiply this side by 2. Well, you can see why I multiplied the left side by 2 is that the 2's now cancel, and I'm just left with x. And then on the right side, I get x is equal to 20. So there's another example. Now, on this one, I'm not going to write out this word problem, but I want to give you a little example of how we generate equations like this, that they might represent something in real life. So let's say I have $250 in a savings account, okay? And I'm buying something where I need, let's say, $360. So I need, let's say I'm buying a computer or something like that. I need $360 to do that. Well, I can put in from my allowance or whatever $10 per week. Okay? And I want to know how many weeks that's going to take me. Now you could do this sort of non-algebraically and think about it and so forth, but bear with me and let's do it algebraically because we're trying to learn how to use this algebraic tool here, basically. This tool of algebra, which is a very powerful tool. So here's the equation I'm making up here. If I have $250, and actually before I do that, I'm going to define a variable, okay? I'm going to say, in defining a variable, I say let W. W is going to stand for the number of weeks because that's I want to know how many weeks it's going to take me to save up to 360. So I'm going to say let W equal the number of weeks it's going to take me. Okay? Weeks in, I barely fit it in there. So trust me, that says weeks. Let W equal the number of weeks. So if I have $250 plus $10 a week times the number of weeks that I save that $10 a week. So I have 250 plus 10W. And if I say that is equal to 360, that should tell me the number of weeks. The W here will be the number of weeks. So if I now solve this equation, it'll tell me how many weeks I need to save $10 a week so that I have my $360 to buy my computer. So I usually undo the addition or subtraction first. So I'm going ahead and doing that. And so what I get here is I subtracted 250 from the left side. Since I did it to the left side, I also need to do it to the right side. I'm left with 10W is equal to 110. Now I need W by itself, and I can do that by dividing this side by 10. Since I did it to that side, I need to do it to this side, and I get W is equal to 11. So it will take me 11 weeks to earn my $360. So that's sort of a semi-practical example of how we can use this. So that's the end to this lesson on two-part equations.